the equation of the plane passing through the point P of x1, y1, z1 is a into x minus x1, b into y minus y1, c into z minus z1 is equal to 0. Now, how to find out the equation, general equation of a plane passing through the point P of x1, y1, z1 is given by a into x minus x1 plus b into y minus y1 plus c into z minus z1. Now, let us see how this is. The proof of this one is very simple. Let the equation of plane B in general form ax plus by plus cz is equal to 0. You call it as 1. Now, since 1 is passing through the point P of x1, y1, z1, therefore 1 implies ax1 plus by1 plus cz1 plus d is equal to 0. Therefore, d is equal to minus ax1 minus by1 minus cz1. You call it as 2. Take the one, substitute in what? 1. 2 in 1 implies x plus by plus cz minus x1 minus by1 minus cz1 is equal to 0. Therefore, a into x minus x1, b into y minus y1 plus c into z minus z1 is equal to 0 is the required equation of the plane. So, therefore, hereafter, how to find out the equation of plane passing through any point means this is the required equation. It's a first degree in what? X, y, z. You can very well observe to find the equation of plane to passing through 4 points, or nevertheless, if you want to prove that any 4 points as coplanar, first you select, say for example, A, B, C, and D be the 4 points. I have to show that A, B, C, D are coplanar points. If I want to show that coplanar points, first let us take A, B, C. The equation of plane, you take its general form. How many unknowns? A, B, C, D, right? Now, equation of plane passing through first point A. Next, on equation, passing through point B. Second equation, passing through point C. Third equations, number of unknowns is equal to number of equations. Solve it and dump out the fourth point, means substitute the fourth point. If it satisfies, then the 4 points are what? Coplanar. 4 points are coplanar. The another one is equation of a plane passing through the point A of A bar and perpendicular to the vector n cap is r bar minus a bar dot n cap is equal to 0. This is called vector form. Previously, what I found out is a Cartesian form. Let us see how you can find out is. The proof of this one is very simple. If we take this one as a plane, this is a plane passing through the point, this is P of R bar, this is A of A bar, this is the what? Position vector, O origin. The position vector of P is what? R bar. The position vector of A is A bar. And this is the unit vector perpendicular to plane. Let it meets the plane at N. Therefore, ON bar is equal to N. This is the plane. This plane is containing one vector, means line joining of A and B. When 2 points are given, you can find out a one vector. This plane may contain one vector or two vectors or three vectors. Let it be any number of vectors it may comprise. If this vector is perpendicular to the plane, it is also perpendicular to each and every vector in that plane, correct or not? Now let us start. What I can write is, let OA bar is equal to A bar, OP bar is equal to R bar, be the position vectors of PVS of capital A comma P. And ON is equal to ON bar is equal to N cap, be the unit vector, so vector perpendicular to the plane, and let it meets the plane in point N. As I told, you can very well observe from figure ON bar is perpendicular to AP bar, which implies, we know from the vector algebra dot product, when any two vectors are said to be what? Perpendicular, then dot product is equal to 0. So therefore, I can write AP bar dot N cap is equal to 0. So therefore, which implies OP minus OA dot N cap is equal to 0. So therefore, I can write OP is nothing but R bar, this is A bar dot N cap is equal to 0. So therefore, this is the vector equation of a plane passing through the point A bar and perpendicular to the unit vector N cap. Perpendicular to the unit vector N cap. So therefore, I can also write, so this is in terms of Cartesian form. How do you write? You can also write as R bar is equal to xi plus yj plus zk. A bar is equal to a1i plus a2j plus a3k. N1 bar is equal to N1i plus N2j plus N3k. N cap you take, R bar minus A bar, you find out a vector, take the dot product. It is quite obvious you are going to get the what? Plane equation in terms of x, y, z. Nevertheless, we call it as what? Cartesian forms of a straight line. From this, I make a move to what? One step. Later we shall analyze this one is R bar dot N cap is equal to what? A bar dot N cap. Let us see what it is in the sequel. Okay. So therefore, this is the what? Vector equation of a plane passing the point A bar and perpendicular to the unit vector N cap. Equation of a plane in intercept form. Intercept form. Right. The theorem says equation of a plane having having the intercepts A comma B comma C on the coordinate axis is x by A, y by B, z by C is equal to 1. Let us see how you can do it. Now let us take this as x-axis, this is y-axis, z-axis, O be the origin. This is the plane which cuts x-axis at A, y-axis at B, z-axis at C. The distance from the origin to the point A is A. You take this point as A, 0, 0. Next, B as 0, B, 0. Next, 0, 0, C. So now, I want to find out the equation of a plane passing through the 3 points. Nevertheless, A of A, 0, 0, B of 0, B, 0, C of 0, 0, C. Followed? So therefore, now what I can write is, the proof of this one is very simple. Equation of a plane in general form B alpha x beta y gamma z plus d is equal to 0. Right? Why, sir? We have already habituated in writing the equation of a plane as ax plus by plus cz plus d is equal to 0. But the context here is, since the intercepts of the coordinate axis made by the plane is A, B, C. So instead of taking A, B, C, better change as what? Notion alpha x, beta y, gamma z plus d is equal to 0. Okay? So therefore, now 1 is passing through A of A, 0, 0. Now 1 implies alpha A plus 0 plus 0 plus d is equal to 0, which implies now alpha is equal to minus d by A. Followed? Next, now 1 is passing through B of 0, B, 0. Yes, 1 implies 0 into x. Now I can write B beta plus 0 plus d is equal to 0, which implies beta is equal to minus d by b, right? Minus d by b. Next, 1 is passing through C of 0, 0, C. 1 implies 0, 0, gamma C plus d is equal to 0, which implies gamma is equal to minus d by C. Take all these values, substitute in the equation 1. Now, substitute the values of alpha, beta, gamma in 1. Therefore, 1 implies alpha x minus d by A into x minus d by b into y minus d by c into z, d is equal to 0. Take out d as a common factor. Therefore, minus d as a common factor. Therefore, x by a, y by b, z by c minus 1 is equal to 0. I can write this one as x by a, y by b, z by c is equal to 1. Is equal to 1. So this is how you can find out the equation of a plane in an intercept form having x-intercept as a, y-intercept as b, z-intercept as c is given by x by a plus y by b plus z by c is equal to 1. Yes. Let us recall the concept of the plane in intercept form x by a plus y by b plus z by c is equal to 1. How to write the intercepts of ax plus by plus g? So note what that is. Intercepts of the plane ax plus by plus cz plus d is equal to 0 is ax plus by plus cz minus d is equal to 0, which implies x by minus d by a, y by minus d by b, z by minus d by c is equal to 1. So therefore, this is how you can convert the equation of a plane which is in the general form into the what? Intercept. Let us give some example. Equation of plane having intercepts 2, 4 by 3 minus 5 by 7 is dash. Okay. Now I can take a is equal to 2, b is equal to 4 by 3 and c is equal to minus 5 by 7. Minus 5 by 7. So therefore, now I can write equation of plane in an intercept form. Equation of plane is x by a, y by b, z by c is equal to 1. So therefore, x by 2, y by 4 by 3, z by minus 5 by 7 is equal to 1. It represents the equation of a what? Plane having the intercepts 2, 4 by 3 minus 5 by 7. Yes. Now by taking the intercepts of the plane 2x plus 3y plus 8z plus 24 is equal to 0. As I told, transfer d to what? RHS. Here d is a what? 24. I can write this one as 2x plus 3y plus 8z is equal to minus 24. So therefore, 2x by minus 24, 3y by minus 24, 8z by minus 24 is equal to 1. So therefore, now I can write x by minus 12, y by minus 8, z by minus 3 is equal to 1. So this is how you can find out the equation of a plane in an intercept form, converting the general equation of a plane into a intercept form. Followed? Right. Now let us discuss about how many types of the planes are there. Now let us take, this is x-axis, origin, y-axis, the z-axis. There are three types of coordinate planes. One is xy plane, other one is yz plane, next zx plane. Now, if I take this plane in this fashion, having the intercepts A on x-axis, B on y-axis, C on z-axis. C on z-axis. So therefore, when a plane possesses x-intercept on as A, y-intercept as B, z-intercept as C, it is quite obvious. A capital A is equal to A 0 0, capital B 0 B 0, capital C is 0 0 C. Then the area of the triangle formed by this line with x comma y axis. Area of the triangle formed by the plane x by A plus y by B plus z by C with the y and z axis is dash, with the z and x axis dash. Let us discuss about that. So now this is one coordinate plane, xy, yz, zx plane are the three coordinate planes. Let us see. Now notice, now look here, the area of the triangle formed by the plane x by A plus y by B plus z by C with first one x comma y axis is equal to f into modulus of AB. We are well familiar in the 2D coordinate system, that is, the equation of a straight line in intercept form is x by A plus y by B is equal to 1. The area of the triangle formed with the line with the what? Coordinate axis is of modulus of AB. Quite obvious. So therefore, instead of 2D, we are going for the plane x by A plus y by B plus z by C is equal to 1. So therefore, I can write second one is y z axis is equal to of modulus of base A. Next, third one is z and x axis of into modulus of CA. So therefore, hereafter, the area of the triangle formed by the plane x by A plus y by B plus z by C is equal to 1 with x comma y axis of modulus of AB, yz axis of modulus of BC, z and x axis modulus of AC by 2. Okay, let us have one example, vivid example as a decide to analyze how to find out the area of the triangle formed by the plane with the what? Three coordinate planes x, y, yz and as well as z axis. Now, one example, the area of the triangles formed by the plane with x comma y axis, y comma z axis, z comma x axis is 12, 9, 6 respectively. Then the equation of the plane, is dash. Equation of the plane is dash. Now I go for the solution of this one is, let the equation of plane B, x by A, y by B, z by C is equal to 1. This plane meets the coordinate axis at A, B, C. Okay. Therefore, their coordinates are A, 0, 0, 0, B, 0, 0, 0, C. Right? So, therefore, plane. Then, area of the triangles formed by the plane with first one x comma y axis is equal to f into modulus of AB is equal to 12, which implies AB is equal to 24. So therefore, now I can write AB is equal to 6 into 4 or 4 into 6 as you please. Next, second one is y comma z axis is equal to half into modulus of base A is equal to how much? 9. Therefore, BC is equal to 18 is equal to now 6 into 3. Right? Now better you change this as a what? 4 into 6 also. You can write it makes no difference. Now third one is z comma x axis equal to half into modulus of AC A6, which implies AC is equal to 12 is equal to 3 into 4. Yes, cyclic order ABC, BCA, CAB, correct? Means among ABC, A is a friend of B, B is a friend of C. It is quite obvious C is also friend of A, correct or not? So therefore, I can write here A is equal to 4, here B is equal to 6, here C is equal to what? 3. That goes without saying. Quite obvious. Yes, in a cyclic order, we could get the values of A, B, C. Followed? So therefore, now the equation of a plane in intercept form is x by A, y by B, z by C is equal to 1. X by 4, y by 6, z by 3 is equal to 1 is the required equation of a plane. Followed? Required equation of a plane. Now, vector equation of a plane in normal form. Okay. What it says, let P greater than 0 be the perpendicular distance from the origin to the plane, and n bar be the vector perpendicular to plane. Then its equation is r bar dot n bar is equal to P. R bar dot n bar is equal to P. Or else you can also write, so n cap also, n cap is the unit vector perpendicular to the plane. I have taken the vector. So therefore, let us see, the plane is taken like this. Now, this is the origin. P of R bar with the point or position vector of that point, and this is the what? A unit vector perpendicular to the plane. Let it meets at this point n. Okay? So therefore, you take this n. In 3D approach, the students must have a good perception in thinking in a space. Even this, don't take it as a unit vector n, that is modulus is equal to 1. Let us take it as P as what? Perpendicular distance. Anyhow it is perpendicular, make it as perpendicular distance. If I write separately, you'll be having more confusions, overlappings. So therefore, now instead of that, what I do is, so P I took it. So therefore, now what I can write is, proof of this one is, let OP bar is equal to R bar be the position vector of a point P and is a point in a plane. And is a point in a plane. N cap be the unit vector. N cap be the unit vector, or n bar. You take n bar with a vector perpendicular to the plane. Let it meets the plane in capital N. So therefore, ON is equal to P. Now, I am going to take theta is the angle between R bar and N cap. Let us. Now, from this triangle, from triangle OPN, what is cos theta? ON by OP. ON by OP, which implies ON is equal to OP into cos theta. Therefore, this is P into modulus of R bar into cos theta. Nevertheless, I am going to write P is equal to modulus of R bar into 1 into cos theta. That one I interpret in a different way. What is that? P is equal to modulus of R bar into N cap into cos theta. What is N cap is a unit vector, right? You take this pair, instead of R bar, you take N cap, it's a N cap. This is also N cap, this is also N cap, right? N cap, you can make it. So therefore, P is equal to R bar dot N cap. This is the vector equation of a plane in a normal form. Why normal form? In particularly because P is the perpendicular distance from the horizon to the plane. So therefore, we call this as what? A normal form. Now this is normal form of the plane in vectors. If I take R bar as xi plus yj plus zk, n bar is equal to n1i plus n2j plus n3k. Take a dot product. n1 into x plus n2 into y plus n3 into z is equal to p. Is it not a Cartesian equation of a plane which represents in the form of ax plus by plus cz plus d is equal to 0. Okay, at present, let us focus our attention how to interpret the equation of a plane in terms of vectors, that is normal form. Okay, note, yes, when the plane r bar dot n cap is equal to p. Here you see, in place of n cap, you can also take n bar. You can take n bar. N bar is a vector, n cap is a unit vector, right? So therefore, r bar dot n cap is equal to p, passes through a origin. Passes through a origin. Passes through a origin. Then p is equal to 0, which implies the vector equation of a plane is r bar dot n cap is equal to 0. R bar dot n cap is equal to 0. With this, we can find out the Cartesian equation of a plane. Cartesian equation of a plane. Now the theorem is, let L, M, N be the DCS of a line, that is, or normal in bracket n cap, and r bar is equal to xi plus yj plus zk. Then the equation of plane is Lx my plus nz is equal to p. Now what I write is vector equation of plane is r bar dot n cap is equal to p, where r bar is equal to, here no need to consider, if you consider, so it makes no difference at all. It is x, y, z, z, k, and n cap is equal to L, M, N. N cap means it's a normal to a plane, perpendicular to the plane. It is quite obvious, it's a normal. When Lm are the DCS of a line, what's the modulus of that? Square root of L square plus M square plus N square is equal to 1. Why DCS? So therefore, now you take xi plus yj zk dot of, yes, li mj plus nk is equal to p, right? Take the dot product. If a bar is equal to a1i plus a2j plus a3k, b bar is equal to b1i plus b2j plus b3k, then what is a bar dot b bar? a1b1 plus a2b2 plus a3b3 followed. So therefore, now what I can write? I dot I is equal to 1, I dot j 0, I dot k 0, j dot I 0, j dot k 0, j dot j 1, k dot I 0, k dot j 0, k dot k is equal to 1. So therefore, I can write Lx my nz is equal to p. This is the Cartesian equation of a plane, where Lm are the DCS of a normal and p is the perpendicular distance from the origin to the plane. Okay. Now, if I take this as 1, yes, in the previous I told r bar dot n cap is equal to p. When that plane passes through the origin, p is equal to 0. Here also p is equal to 0. Let us see. when one passes through origin, then 1 implies 0, 0, 0 is equal to P. Therefore, I can write P is equal to big 0. So therefore, now 1 implies Lx Mi plus Nz is equal to 0. Followed? How do you say when a straight line y is equal to mx plus c passes through origin? C is equal to 0. Quite obvious, y is equal to mx. When you do not have a constant, it is quite obvious. It passes through the what? Origin. Now, independent proof of the theorem. Proof of the plane. What is statement comes? Let L, M, N be the DCS of a normal and P be the perpendicular distance from the origin, then its equation, then the equation of the plane, is Lx plus My plus Nz is equal to P. Let us take this plane, right? Now you take M, this is O, P of x, y, z, this is 0, 0. This DCS of this one is L, N, and this length is what? P. I start, the proof of this one is very simple. Let capital M be the projection of the origin, in the plane. And P of x, y, z be the point in a plane. ON is equal to P. And ON bar is the normal. And it has the DCS L, M, N. So therefore, ON is nothing but a length. A length is nothing but projection of OP bar on the line. Having the DCS L, M, N. Yes, we know that from DCS and DRS. If A of x1, y1, z1, B of x2, y2, z2 be the line joining of the 2 points AB, the projection of the line segment joining A of x1, y1, z1, B of x2, y2, z2 on the line having the DCS element is given by L into x2 minus x1, m into y2 minus y1, n into z2 minus z1. So therefore, I can write this one as L into x minus 0, x2 minus x1, followed, plus m into y2 minus y1, y minus 0, n into z2 minus z1, z minus 0. Therefore, this is nothing but a p. Therefore, it is quite obvious, Lx my plus nz. This is how you can find out the equation of a plane in a normal form independent of all those vectors or something. So therefore, by using the concept of projection, we could establish the equation of a plane in a normal form as Lx plus my plus nz is equal to p. If this passes through origin, put x comma y comma z is equal to 0. This is 0, 0, 0, p is equal to 0. Therefore, the equation of a plane is given by what? Lx plus my plus nz is equal to 0.